Wow, have a look at all this. Makes you hungry. Are you hungry? Well, how much do you want to eat? Oh, somebody's been hard at the pizza down here. And what fraction is left for you? And that's the topic here, fractions and decimals. So how much are you going to have left? Why are those 3 eighths? We better look at that. Oh, thank goodness the cake is still all intact, but I might need most of that, so you might miss out there. Anyway, all this food is very bad. It's very high in calorie and kilojoule value and too fatty, so we've got to move on down now and do some maths instead of eating this stuff. So come down here and let's have a look. And I think you've got the idea. And a fraction is like represented with this picture here. We've got 3 out of 5 parts. So let's start with that language, 3 out of 5 parts. Or we are dividing something into parts. A divided into B equal portions. That's the idea. Okay, so it can be written like this, or A over B is how we usually do it. And so the denominator, there's a word, the bottom line of the fraction, is the number of portions we divide the whole into. And the numerator is the top line, is the number out of the total that we want to consider. So this is 3 out of 5 here. 3 fifth segments of this circle are shaded in. 3 out of the 5 segments there. Okay, and so this is called a common fraction. So it's a symbol in maths to mean exactly that, dividing up into equal portions. So let's work with that. You don't actually have to have done much of this before. This presentation is going to pretty much start at the very beginning. And the screen clippings here are from Hayes and Harris publications. You might have a look at their Year 8 Australian curriculum book there, and that would be useful. All right, come down and let's have a look at the words we have for these fractions. 2 out of 3 is called a proper fraction. And that's when the numerator is less than the denominator. This is the top line of the fraction and this is the bottom line. Okay, so where this is so many parts out of a bigger number, in other words, you're not taking the whole. But 4 over 3 is dividing 4 into 3 parts. So you're going to get more than 1 in each value there. So this is called an improper fraction because the top line is larger than the bottom, and you're actually dividing up 4 units into 3 equal parts. Each one's going to come to more than 1 unit, if you like. And then 2.5 is a fraction part and a whole number part. So it's a mixed number. It's really 2 plus a half. And we're going to be working with those a bit later on. So we're just starting out trying to get our head around the way in which we can represent fractions. Okay, come down, let's look at an example here. And here one, convert 2.5 to an improper fraction. So 2.5 means 2 plus a half. 2 is 4 divided by 2, isn't it? So why have we done that? Well, we've got halves here and wholes here. So our thinking, here you are, what are you thinking? Here you are, you're happy because you're doing maths. And what you're thinking in that brain of yours is this. You're thinking, well, I've got a half. How many halves in the number 2? Because if we have both of them written as halves, 4 over 2 or 4 halves, and 1 half is 5 halves. So you're thinking that, so you go like this. Well, there are 2 halves in one unit, so there would be 4 halves in the number 2. And therefore you have 4 halves plus 1 half is 5 halves, or 5 over 2. That's the thinking. That's how it all works. And remember the hierarchy, Huddy's hierarchy. You need to say, well, I'll learn a basic rule down the bottom, or algorithm. What's the concept that I'm trying to understand? And can you get up close and personal with it? So you say, hey, I see it. Well, let's see it then. This is trying to see it here. But the rule is simple. If you've got 2.5, you multiply the 2 by this number here, the 2, so that becomes 4, add the 1, that's a total of 5 halves. Now that's a little rule, multiply that up there to get 4, add the 1, and now you're all in halves, so that's 5 halves. That's the idea. But the thinking of it, to really understand that quickie method, is like that. Let's do another one. Let's say 3 1/4. Okay, so there are 4 quarters in a whole, so multiply 4 by 3, that's 12 plus 1 over 4, or 13 over 4. That's working right down the bottom level here of a rule. And what I want you to do is to think about what you're actually trying to do. Changing 3 into 12 over 4. There are 4 quarters in 1 unit. In 3 units there'll be 12 quarters. And 1/4, 12 dogs plus 1 dog is 13 dogs. Because you think of 12 over 4 as 12 lots of 1/4, and then plus 1 lot of 1/4 is 13 lots of 1/4, that sort of stuff. Okay, so when you're doing this rule, that by that to get 12, add 1, then try to understand that's what's going on. Okay, try and get up close and personal with the maths as you go up the hierarchy there. Come down and let's have a look and see what we've got. There's some positive and negative things you can do with fractions as well, just like we said before with integers, positive by a negative or a negative by a positive, and the result is negative. We went through the maths of that back in the earlier presentation on integers or numbers in general. So here, if we have -1 divided by 2, it means split it into 2 equal parts, and the answer will be -1/2. A negative divided by a positive is a negative, because what you're doing is saying, here's -1 on the number line, we want to divide it into 2. So the answer will be still on the negative side, isn't it? That's -1/2. That's the idea of those rules of signs. And 1 divided by -2 means a positive divided by a negative is a negative. And how can you divide by -2? What's the idea there? Well, when you have 1, let's take 1 over here, a +1, we're splitting it into 2 parts, so this is 1 divided by 2. Now, what does that imply about 1 divided by -2? When you change the sign there, that's the definition of a negative sign, doesn't it? It implies opposite direction. Okay, so you end up at -1/2, not +1/2. And that's the answer there. And that's the reason behind saying a positive divided by a negative is a negative. And we just learn the rules off, and you've got to know those very quickly, but you can unpack it all on the number line there. So go back and have a look at that again. In general, it doesn't matter where you put the negative sign, top line, bottom line, or just right out in front. You can't put it in top and bottom, though, because that would be a negative divided by a negative, which is a positive. So these forms, this is very important, these forms are all equivalent. Okay, and sometimes it might be more useful to use one than another. Okay, probably the most common one is this, -2/3, like that. They're level with the line. Okay, but you could call it -2/3 or 2/3. I think these two are the most useful later on in maths. It's amazing how many people doing senior maths courses still are not sure about that. So try to learn that off now. You can put the negative top, bottom, or in the middle. Okay, so what about what it means on a number line? I've done a little bit of number work there. So if you're trying to do it on a number line, the first thing is to look at the scale. So if you're working with a fraction, what have we got here? Fifths everywhere, mate. Fifths. So you'll divide all your units along the number line into 5 equal parts. meaning you can move in fifth land. Oh, what's that? You can move 1/5 very easily along such a scale. And that's what we want to do, because all our fractions have got over 5 equal parts. So let's divide our units up here in 5 equal parts. Makes it easy to move, eh? So 1/5 is one of those parts to the right. Neg 2/5, remember? Negative direction, 0 and positive direction. That's the meaning of negative in maths. An opposite direction is all you've got to remember for understanding a negative in maths. Opposite direction. And we're going to do a little bit of revision of that right now. So neg 8/5. Well, here's neg 1, which is 5/5. Okay, you've got a hole. Back on the pizzas there. I don't want to make you hungry, but thinking back to the pizzas. If you had 5 parts out of 5, that's the whole pizza. You can't eat that. That's far too fattening, mate. And so then we want another 3/5 in the negative direction, meaning neg 8/5 down there. Do you get it? You might talk to your teacher and other students about that. Let's come up and do this little dude up here. This is 1, so we've gone to 1, which is 5/5, isn't it? 5 out of 5 is the whole, is 1. And then we've added another 4/5, so we've got 1 4/5, or you could say it's an improper fraction, 9/5, or 9/5. Okay, getting the hang of this. I hope you are. You might have to go back and just replay it and go over it a few times maybe. All right, come on down and let's give you something to get into now. Okay, not allowed any food yet. You haven't done any work, mate. So once you've done all this, you could go back and have a piece of pizza, or maybe a piece of my cake. I really want most of that for myself though. So there you go. I've done all this work for you, so I think I deserve a cake, eh? Anyway, so here we are. Describe the following as proper fractions, improper fractions, or mixed numbers. And I want you to go through and see if you can use the rules here and what I've shown you to answer these questions. All right, so pause the presentation and have a go. And as you do a question or two, go and check your answers so you make sure you're on the right track and you don't perpetuate an error. Okay, I'm going to show you the answers now. Here we go. All right, there's some answers for you. Now, check these out. You want to get this right, just starting out in math land here with fractions. You want to get the language right so that everybody's on the same page with what's happening. All right, so mark your work. We're going to go on now. That's not right. So come down here and let's have a look at what makes 2 fractions equal and why that's the case. Now, we're going to have a monkey rule here, just a basic rule that you learn off like monkeys copy each other. Then we want to unpack that a little bit and see why it works. So here's the rule, we can multiply or divide the top line and the bottom line, numerator and denominator of a fraction by the same. Can't multiply by 0 because the fraction would disappear. Multiply something by 0 is 0. So we won't do that. But we can obtain an equal or equivalent fraction. So if I multiply 1 out of 3, top line by 2 and bottom line by 2, I get 2 out of 6. If I multiply top and bottom by 3, it'd be 6 out of 18. Or I could divide the fraction 15/20, divide top line by 5 is 3, bottom line by 5 is 4, and they are equivalent. So this is sometimes when you divide top and bottom called cancelling out. You're actually dividing top and bottom by the same number to keep the fraction the same, equal or equivalent fractions. Okay, now let's have a look at going up the hierarchy there and saying, what's going on here, mate? Okay, so let's have a look at a third. Here we go. This is the first one. So a third, something like that. Not too bad, I suppose. So each of these is a third. Now, if we change it into sixes, now each third contains, if we halve that, half of a third there, and half of this third there, and half of this third. Oh, what do we got? We've got 1/6 in each of those. So we've divided up our thirds into sixes. Let's take this top third here. Oops, hang on, I've lost my whole thing here, mate. So here we've got our there, and if we make this the third that we were looking at, and we've divided up into sixes. So that third, we've broken it down, halved it, comes to 6. Okay, halving it. So that it's now 6 pieces. So we're saying that a half of a third is a 6, and therefore a third is 2 over 6. That's the reasoning. But gee, that's a lot of sussing out. That's a long way. I want you to do that to understand the concept and the idea. But what's the quickest way? Look at this. What's the quickest way of going from there to there? Multiply top and bottom by 2. Okay, and you can do it again. You could divide your top third now. Here, we're doing this. That's a third, and we've got the others down here, whatever. Hang on. Down there. We've got those, but now we've got this top third around here. We've got 2 6, and we want to say, well, if we divided that into threes, each 6 into 3 equal parts, like that, then these are, how many would you have in the whole circle? They'd be 18ths. If you divided each of the thirds into 6 more parts, that'd be 3 by 6 would be 18 parts. So each of these narrow pieces now would be an 18th. So our third is now 1, 2, 3, 4, 5, 6 18ths. Okay? A lot of work, a lot of work. What's the easiest way of going from 2 6 to 6 18ths? Multiply the top by 3 and the bottom by 3. So that's where the rule comes from. I want you to really keep asking. Ask your teacher, why does that work? Why am I multiplying top and bottom by the same fraction? And the same thing goes with our division here. Going backwards and dividing top and bottom, you're going to look at pieces of pie here and how many pieces you've got, and are they equivalent? So 1/3, let's go over, is 2 6, because I'm splitting that into 2 parts, so I'm multiplying that by 2. If I multiply this by 2, then the parts stay the same here in terms of their ratio, or how many. You're dividing these segments up, the third, into smaller and smaller pieces. All right, so we have our rule here. Multiply top and bottom of a fraction by the same number, and you won't change the meaning of the fraction. Or you can divide top and bottom. Let's go and have a look at some. So here we are. We're going to say, can you change 3/4 so the bottom line or denominator is 32? Because you might want to do a problem like this. 3/4 plus 5 30-seconds. And you can't add them very well because these are quarters and these are 30-seconds. It's like saying 3 dogs plus 5 cats. Can't do that. Okay, so what are we going to do? If we want this to be equivalent to 30 seconds, that's dividing each a quarter up into 8 more parts, so you've got 32 overall in your whole. Then what are you going to do? Well, here we are. Multiply by 8 to get 30 seconds. Multiply the top by 8 to get 24. So then our problem of 24 30-seconds plus 5 30-seconds is 29. You can do it if you change the 3/4 to the same unit, to the same denominator. So same number of parts. So this is 24 30-seconds, 24 dogs plus 5 30-seconds. 5 dogs is 29 dogs or 29 30-seconds. So you must remember, look at the bottom line first to change it, and then you've got to match it with the same multiplication of the top line. And of course you could bring it back if you like. If you had 24, if we want a denominator of 11 for 24 on 33, we go to this line first. If we want to reduce the denominator to 11, we'll divide by 3. But you've got to do the same to the top line to keep the number of parts out of the total that you've got there in the same proportion, the same meaning, how many out of how many. So do you agree? 24 out of 33 is 8 out of 11. That's what we're saying. All right, so concentrate on the rules, but just think about dividing up a pie or something like that as a way of understanding what you're doing. Okay, so come on down now and have a look at some simplifying some fractions here. We can do a simplification by dividing top and bottom by the same number. We've just covered that. But we could, instead of having a big number here of 25ths, if we divided top and bottom by the lowest common, the highest common factor, the HCF, which we did in an earlier presentation, what is a factor they both got? Well, 5 goes into 10 and also into 25. So let's divide top and bottom by 5. So you get 2/5. And negative 3/4. Let's leave the negative out the front this time. And what is the highest factor that these two share? Highest common factor they have in common. And of course it's a 3. And you could divide 3 by 3 and 24 by 3, so you get neg 1/8. Okay, highest common factor is 3 there. All right, get the idea. We're playing around with fractions in different terms so that we can add and subtract them better, which we'll do a bit later on here. So come on down, and here's a chance for you to have a go down in this problem. What? There's some meerkats here. Aren't they cute sitting there? All right, okay. I don't know whether they bite. They look to be a bit funny there, looking at us like that. Anyway, steer clear of them. All right, I want you to go and change the denominators here from what we've been doing. You're multiplying top and bottom by the same number or dividing top and bottom by the same number. And you'll see a use for this later on. Okay, so here, the idea of finding lowest terms. So the idea of dividing top and bottom so that it's the simplest or the smallest number in the bottom line or the denominator. All right, pause the presentation and check it out. And as you do a question, I would go and fast forward the presentation, have a look at the answers, only for that question, and then go back. So you're checking that you're not making a mistake along the way. All right, come down now and let's have a look at the last question. That's 5. And have a go, making up your own fractions here from information. And let's have a look at the answers. So here are all our answers. Make sure you've got them right and check out with your teacher or classmates or redo the problem and see if you didn't get it right, go back and see if you can get it, to get the idea. All right, let's go on and have a look. And now what we're going to do is operations with fractions. You might have done some of this before, adding and subtracting. So if I have, 3/8 of the pizza, I am getting hungry. I'm getting so hungry doing this work. And somebody else has a quarter of the pizza. How much pizza have we taken overall? Okay, so what we've got to do is what I indicated before. We want the lowest common denominator. Why? Because this is 3/8, 3 lots of an eighth, and this is 1/4, 1 lot of a quarter. Okay, so the idea here is you can't add them up. It's like 3 cats and 1 dog. So what we need to do is to change the quarters to eighths. Okay, so we're going to get the lowest common denominator. Okay, what will they both go into? So here, it's pretty friendly because 3/8 we can leave, but a quarter we'll multiply top and bottom by 2, so that becomes an eighth there as well. So this is 2 by 1, 2 out of 8, so that's 3 dogs plus 2 dogs is 5 dogs, or 5/8. I'm using the dog idea because that's the concept here. If a number is common, then you, here in the bottom line, the denominator, then you can call that an eighth, or here, yes, an eighth, and we've got 3 of them, and then we want 2 eighths here so that we can add them up. 3/8 and 2/8 is possible, but 3/8 and 1/4 cannot be then added that easily. Okay, you've got to have the common denominator. Let's have a look now and see an example here. So 3/8 plus 1/2. So let's change the half to the common denominator of 8. Something they'll both go into, the smallest number. We don't want those big numbers. Okay, so we'll multiply now. How do you know to multiply by 4? You look at the bottom line. We want them to have a common denominator. So we have to multiply the 2 by 4, and then, so that's the first observation. and then you go up and do the second step, multiply the top by 4. So you've got 3 dogs plus 4 dogs is 7 dogs. What about this one over here? Got a subtraction in there. Well, you can't take dogs away from cats. So here, these 3 have to be put in terms of each other. So none of them go into each other, so we have to find the lowest common denominator. The lowest common denominator is 12 here. So we'll make them all 12s. So here multiply that one by 3, then you've got to multiply its top line by 3. Made it 12s. Multiply this one by 4, then do the top line by 4. So that's 8 12s. And this one by 6, then the top line. So 6 over 12. So if you add up 9 dogs, then you lost 1 dog, lost 8 dogs, you got 1 dog plus 6 is 7 dogs. Okay, so the idea that you're looking for something in common so that you can work out in the long run how many of those that you've got. You've added some and taken some, how many you've got left. How much of that pizza's left? I'll get rid of that. Okay, so that shouldn't come up. All right, let's go on now and have a look at another example. And here we have some mixed numbers. Okay, so this time we'll write them as improper fractions. 2.5, remember 2 times 2, there's 2 halves in one, so if you've got 2 whole numbers there, 2 by 2 is 4 halves and 1 is 5 halves, and here 5 times 1 is 5 and 2 is 7/5. Remember this little way of converting a whole number to fifths. Multiply by the 5, add the 2. So you've got a total of 7/5. Now, you can't add 5 halves and 7/5. 5 dogs take 7 cats. No, we're not adding, we're subtracting here. We've got to have them in the same units, if you like. So what's the lowest common denominator? 10. So to make this into tenths, I focus on the bottom line first, times it by 5, and then times the top line by 5. So I get 5 over 2 is 25 over 10. Then here, let's work on making this common as a 10, so we multiply by 2, then come up here and multiply the top line by 2. So we have 24 dogs, take 14 dogs is 11 dogs, okay? Or 25 tenths, take 14 tenths is 11 tenths. All you're really doing is taking away the 14 from 25. How many tenths you got left? So if you look at 11 over 10, 10 goes into 11 once. 1 10 is 10, and 1 over. So you've got 1 and 1/10 as a mixed number. In this situation, we do usually consider the mixed number form as the simplest form for an improper fraction. Okay, let's go down and do some. So here's some for you. We'll just come down here a little bit. There's question 1 to 4, and 5 is coming up. So remember, you can't add up dogs and cats. You must have some common unit to add up, and that's halves or quarters, and that implies you want a common bottom line, a common denominator. Okay. All right, so have a go at those. Check your answers as you go. Don't wait right till the end and find that they're all wrong. Okay. Check a few as you go. So pause it and go through to question 4. I'm going to show you question 5 now. Let's come down here a little bit. Oh, there's question 6 as well. Forgot that. Okay, and you can check it on the calculator as well. There's a fraction button on most calculators. A, B over C, that one. Play around with that and you will find a way of doing it. 1 fraction key 5 will give you 1/5 in run mode on most calculators. All right, let's go now and have a look at the answers. There are our answers. We want to do a little bit more. I hope you're not getting too tired. Remember, there's still that pizza left back on that first screen if you're getting hungry. All right, let's go on now. Multiplying and dividing fractions. And this is an interesting one. To multiply 2 fractions, we multiply the numerators together, top lines and the denominators together. A over B times C over D as you multiply these together and these together. Okay, so let's look at it. 3/7 times 2/5. 3 by 2 is 6, 7 by 5 is 35, 6 over 35. Here's a mixed number, so it's 1 by 3 is 3 and 1 is 4/3 times 3/5. Now because these are going to make up one big fraction, like this, you can say, oh, I can see, or you can divide top and bottom by 3, or commonly called cancelling. Okay, so it's 4 over 5. You don't have to go to 12 over 15 and break it down from there, because you can spot the idea of dividing 3 by 3 is 1, dividing 3 by 3 there is 1. Now, the interesting question is, why do you do that? Okay, why do you multiply the tops together and the bottoms together? Well, let's have a look. Let's say we've got a fairly simple problem. So we'll say we've got here, we'll make it a quarter. We've got a quarter here as our fraction. And we have, let's say, 3 lots of a quarter. So you could think of that as 3 over 1 times a quarter. Now we know the answer, 3 lots of a quarter is 3/4. But how would you do it if you thought of 3 as 3 over 1? Oh, I can see. It'll be 3 by 1 is 3, 1 by 4 is 4. So actually, when you are thinking about multiplying fractions, that's what you're doing. So let's say we've got, what, 2/3 of 9. Okay, so 2/3 of 9. Now a third of 9 is 3, dividing that into 3 parts, and 2/3 therefore is 3, so 2/3 of 9, 1/3 is 3, 2/3 is 6. Okay, all right, so what have we actually done here? A third of 9, sorry, 2/3 of 9 is that, call it 9 over 1, that's 18 over 3, okay, and therefore, oops, hang on, I've got this here, that's 2/3 of 9, 6 over 3, did you notice that? 18 over 3, which is here now 6, okay, so 2/3 of 9 is 6, 1/3 of 9 is 3, oops, I've put a 3, I'm still wrong here, 2/3 is 6, way back there, just check all that, because that got confusing. A third of 9 is 3, 2/3 will be 2 lots of 3 is 6. So that's the idea that we're doing here, that you could multiply tops together and bottoms together, okay, and you can extend that to 2/3 of what? 2/3 times 6/7. What would you do there? 2/3, so here you could say that's 2/3 of 6, and then you've got a seventh of that. And you could break it down, and in the end you would see you multiplying that and multiplying that together, and you could use that notion to go on to understand the rule. So the idea here is it's numerators together and denominators together, and some idea of what's going on there from this discussion here. All right, come down and let's have a look at some problems. Okay, well, first of all, we're going to do a division. A over B divided by C over D. So you could say it's this. Wow, something like 3/4 divided by 2/3. Oh, what are you going to do with that mess? Division by a fraction. Well, let's see if we can understand it. Let's say we've got 3/4 divided by 2. You could call that 3/4, and I'm dividing it by 2, so I'm finding a half of it. So I'm doing that, which is 3/8 from our multiplication rule there. Okay, so 3/4, let's divide it by 2/3. Okay, we're trying to find how many 2/3 there are in 3/4. One little trick you could do, you could multiply top and bottom of this fraction by 3. And the top line would become 9/4, and the bottom line would become 2. Okay, 3 by 2/3 is going to be 2. And so we would have 9/4 times a half, which is 9/8. And now what's the easiest way of doing that? Well, here's what they say. 3/4 divided by 2/3 is you multiply by 3/2. You invert and multiply the bottom line, 9/8. Now that's a rule, but this is some idea of how it works. Okay, so the rule is, if I have 4 divided by 1/3, it's 4 divided by 1/3, 4 times 3/1, or 12. And 1 1/3 divided by 2/5. Change it to 1 by 3 is 3 and 1 is 4/3, divided by 2/5. Invert and multiply. Or this is called 5/2 is called the reciprocal of the bottom fraction. So you invert the bottom fraction and multiply. So that rule is quite an unusual one, isn't it? How does division become multiplication by the denominator's reciprocal, or turned upside down? How does it become multiplication? And the idea here is that you could go actually a little bit further with this and try to understand 4 divided by 1/3 is how many thirds are there in 4 wholes? How many thirds are there, in one? In one whole, there are 3/3. So in 4 whole numbers, 4 wholes would have 12 1/3s, wouldn't they? So that's what we're saying. In 4 units divided up into thirds, well, 1 unit divided up into thirds comes to 3/3. So 4 units will have 12 thirds. So if you're over here saying, I want to divide 4 by 1/3, means how many thirds are there in 4? And the easiest way, rather than go through all this, is to go to multiply by the reciprocal of 1/3. Invert and multiply. So this is a rule method or an algorithm method, but you can try to unpack it with diagrams here. So you're coming up the hierarchy to getting up more up close and personal as to where the rules come from. Why do you change a division by a fraction to multiplication by the reciprocal, or turned upside down, invert and multiply? Okay, so if you think about all this down here, you'll get some idea of where that rule comes from. Mind you, you can't go back and do this sort of thinking for every problem. You've got to move quickly to the answer, and that's why we do have rules. Okay, let's go down now and give you a go, and we're going to finish there. And we're just showing a little bit of the answer, so that we're just coming to there. So we're going to finish up now. So I want you to go through, remember the rule for multiplication. It's numerators together, multiplied together, over denominators multiplied together. That's the rule, and I hope you can remember why it works. And then division by a fraction is one fraction divided by another becomes the top line multiplied by the reciprocal. Turn it upside down. And that's simply a quick rule of working out what the answer is without working out the fractions of a pi and so on. Well, look, I hope you enjoyed all that. There's a lot to remember there, and I have a lot of practice to do. But anyway, it's a cheers from me now. If you're tired and hungry, then after I show you solutions, you can go back and have something to eat from that first page. Well, you've earned it. Here are the answers now. So mark your work. If you've got a few right, go and have something to eat. You've earned it. See you in the next presentation.